In this video, we're going to look at how we find the integral of ln x. We can also use the same method to find the integral of x times ln x, or maybe x cubed times ln x. In fact, any power of x or a combination of powers of x, multiples of powers of x times ln x. It will all work the same, as we will see. Okay, to do this, what we want to do, first thing you want to do is rewrite your integral as 1 times ln of x dx. And then what we're able to do is use the integration by parts. Now, the integration by parts formula is the integral of u dv by dx integrated with respect to x is equal to uv minus integral of v du dx dx. Now, generally what you do is you pick the u such that it is a simpler function, so that your du by dx is a simpler function, I should say. And that means this integral here, you can actually integrate. But in this case, this is a very unusual one. Over here, what we're going to do is we're actually going to let our u be equal to ln of x, and our dv by dx is equal to 1. And we'll see why that is in a wee second. So if you differentiate your u with respect to x, if you differentiate ln with respect to x, you just get 1 over x. And if you integrate 1 with respect to x, you will just get your x. So we write down our integral then, which was 1 ln of x dx. And then if we can put it into this formula then, we know our u was equal to ln of x. I'm just going to put that in a bracket. Our v was equal to x. And then our integral then of v, which is x, times our du by dx, which is 1 over x. I'll zoom in on this again. So that's what we have got down to. So then I will just write that as x ln of x. And this bit has been integrated, so you don't do anything else with it. And the next bit, let's tidy up before we can integrate. X times 1 over x would just be 1. And then we'll write that down again, x ln x. And then if you integrate 1, you will just get x, so that's minus x. And remember, you'll have a constant of integration as well. Okay. Now, I'm going to use that one. So that's how you integrate ln of x, a standard one. I'm going to use this one and change it. We're going to change this to b. I'm going to change this wee bit. I'm going to change my thing here. And we'll see how it can work if it was a different multiple. So I'll just pick something. What do I pick? I'll pick 7x squared. So my this is now 7x squared times 7x squared times ln of x. 7x squared times ln of x. And we'll see it will work the same. Let me tidy up, that's a mess. 7x squared times ln of x. So again, your u is equal to ln of x, your du by x is 1 over x, your dv by dx is 7x squared. Raise the power by 1, you'll have 7x cubed, but divide by the new power, that's divided by 3. And then what we had, we were integrating 7x squared ln of x. So let's see the formula, it's uv, so that's going to be ln of x, that's my u, times my v, which is 7x cubed over 3, then minus the integral of my v, which is 7x cubed over 3, times my du by dx, which is 1 over x. We'll zoom in on that so we can actually see it. And then this left-hand bit has already been integrated, so it's fine. We'll leave it as it is. Just switch the order around, make it look a wee bit prettier. And then over here, if you do 7x cubed over 3 times 1 over x, that would just give you the integral of 7x squared over 3 dx, which you can integrate. So that's now 7x cubed over 3 times ln x. That's already been integrated. Raise the power by 1. You're going to get x cubed. Divide by the new power. So dividing, we had 7 over 3, and dividing by 3 is the same as multiplying by a third. So that's really going to be 7 over 9. X cubed, and then remember your constant of integration c. So you can see how this can be used for any multiple of, any multiple of a power of x times ln x, that's what you do. So basically, the takeaway for this is you always let your u be equal to your ln, and then you can get your du, and then if your u is equal to your ln, then dv by dx is equal to the other part of it. And that's it done using integration by parts.